Okay, great. Um, yeah, so hi everyone. Good morning, or at least it's morning where I am. I'm Matthew, and I'm a postdoc at Harvard University in the Edge Computing lab. I work with Vijay Reddy, who is a well-known figure in the TinyML community and the Edge computing community. And today I'm going to be sort of introducing everyone to um, something we've been working on for about a year now, which is machine learning sensors. And specifically, I'm going to go into sort of what a machine learning sensor is, uh, what it's capable of doing, and then some of the sort of challenges and opportunities surrounding this kind of different paradigm of intelligent sensing. So just to kind of motivate things, we're all familiar with different applications of machine learning at this stage, especially now with things like, ChatGPT, GitHub Copilot, we have Midjourney and all of these generative AI tools. And then we've seen it in various forms of social media. You have recommendation systems and stuff. And most of the computation for these is done on cloud computing hardware. And traditionally, these are in data centers. And now we're starting to see it sort of bifurcate into sort of, we have these larger models with GPT-3 and 4. We're going to sort of billions and billions of parameters. And then we've got the other way, we're going to sort of smaller and smaller devices. So we went to sort of smartphones, and then now we have this kind of gateway to the cloud through these IoT devices. And now we have embedded machine learning on these like microcontrollers, where we have really resource constrained devices being able to do machine learning. And most people here are familiar with that idea. But this is a really interesting opportunity because now we can perform machine learning at the level of the sensor. And there was a study in 2018 which basically estimated that we produce about 5 quintillion bytes of data every day from these IoT devices. And for context, that's about 1 million bytes for every person on Earth. And this was 5 years ago, so it's probably a lot more now. And so this is and a lot of this, so less than 1% of this is actually being used for any usable purpose. So there's an underutilization of this data that we can tap into. And so this presents sort of a great opportunity for us to, now we have this capability with TinyML, we can unlock a lot of use cases that didn't previously exist. There's business intelligence we can extract information from that wasn't previously available. And so, this is the TinyML paradigm that we're all very familiar with. So this example here is a person detection sensor. So on the left, we have a camera here, which is looking at a person. And the way this application works is if it sees a person, it says, yes, there's a person, and it gives you a binary output of 1. If there's not a person, it says there's not a person, it gives you a binary output of 0. And so this camera is taking a picture. You have an array of pixels. The data is being shipped to this processor where this model is being run, and then you get this output, which you can then send the output or the data to the cloud, or some action can come out of it. And this idea we've described as the sensor 1.0 paradigm. You have the data moving around, you have separation between the sensor and the compute, and there's a lot of problems associated with this paradigm, or because of the way this paradigm works. So for example, you can imagine if I have an array of pixels, let's say I have a picture of me on the sofa watching television. If the TV just wants to know if I'm there and say yes or no, then it only needs that one bit of data. If it has a picture of me, there's a lot more information that's enshrined within that picture. It could say how many people are in my house, how many children I have, genders and ethnicities of people. It could even tell like my socioeconomic status by like what my house looks like. And so, there's a lot of like auxiliary information that's embedded within that image, which you don't need for that application. And this presents lots of like implications in terms of privacy and security. You get into these interesting debates you've heard of people saying like, oh, I found a microphone in my thermometer or my thermostat, like Google is spying on me, or people just buying a TV and then 6 weeks later realizing that it has a camera in and they had no idea. And this presents some pretty interesting questions surrounding like TinyML, which is if you have a house of the future, which is going to have many, many, many of these devices in, sort of how do you architect these systems so that we kind of consider all of these problems and we have, we're able to solve the problems we want to solve, but we want to do it in a way which is robust and also doesn't violate people's, privacy, but it also makes it user friendly and easy for developers to do. And so the answer we came up with was this idea of the machine learning sensor. And, if we take those two things separately, everyone knows what machine learning is, most likely at this point. Everyone's kind of familiar with the concept of what a sensor is. You have a temperature sensor, it measures temperature or something. It's kind of exactly what you think it would be. We take those two ideas and we kind of squish them together into this singular device. So the definition we came up with for a machine learning sensor is that it is a self-contained system. So self-contained in the sense of I could go to a shop and I could buy, a device in the same way that I would buy a thermometer. It uses on-device machine learning. So this is the TinyML component, and it extracts useful information about the physical world. So this is the sensing element. We have some kind of transduction of physical variables into a signal that we can interpret. And then it reports it through a simple interface to a wider system. And the key word here is simple. So instead of taking this raw data, which in the case of this person detector would be an image, we would instead extract sort of metadata from that, and that's the data we'd be shipping around. So like I said, you don't need to know everything about that picture to say if there's a person or not. You just need that one bit that says yes or no. And then it would report it to a wider system. That could be something like a Raspberry Pi that the sensor is connected to, in the same way that you would connect other sensors to these devices. So you have some kind of application processor on board here. And so here's an example of an ML sensor that currently exists with by one of our collaborators, Useful Sensors. And so this can do person detection, gaze detection, and face recognition, I believe. And so if we take our sensor 1.0 paradigm, this sensor enshrines those first two aspects of it, of the physical sensing and the processing. And it just kind of contains them into this separate system here that we call the machine learning sensor. And you can have security on board, you can make it a secure enclave or have encryption and things. And then you would ship the output of this onto this application processor. And then at that point, it's pretty much the same as the sensor 1.0 paradigm here. So it's a subtle difference, but an important difference, I think, because now the data is not being moved around. So we have, the privacy of the individual is protected. We also have increased security, because now if someone hacks into this application processor, there's no way of them accessing that raw data on the ML sensor. And then also this means we can have this kind of modular approach, which is much more user-friendly, because now the machine learning aspect of the sensor is fully abstracted. And so also feel free to post questions in the chat and we'll discuss them at the end of the talk, because I'm sure there'll be several. So we've come up with 5 guiding principles that we believe kind of should be embodied within this idea of the machine learning sensor. And the first one, I'm going to go through each of these separately, but the first one is that we kind of have to raise the level of abstraction. And we know computer scientists love saying this, but like, what does it actually mean? And the idea here is that you really shouldn't have to be an expert in machine learning or in sensing to be able to use one of these devices. In the same way that you have computer architects and software engineers, and yes, they have to be able to work together, but they don't have to understand what each other does. It's like a whole separate community, and they have their expertise. It's the same idea here. If I'm developing devices, I shouldn't have to, go and build my own model, my own data set, do the training and testing, build a piece of hardware. I should only have to take the sensor and use it for the thing I'm trying to do. And so there's an element of like user friendliness in terms of the developer that we want to enshrine within the concept of the ML sensor. And so you could imagine, in the same way that you go on like DigiKey and you look for temperature sensors, you would have the same thing for machine learning sensors. So you go on here and you say, okay, I live in Boston. Boston gets pretty cold, so I want a sensor which, can span the full range of temperatures of Boston. And maybe there's other requirements I care about, like voltage and stuff. And then if not, I want to pick the sensor that's the cheapest. And you could imagine having different vendors here or different types of machine learning sensors that have different characteristics. Maybe some work at further distances, maybe some work in lower lighting conditions. And you could imagine different arrays of these types of sensors being sold on different platforms. And this is kind of a corollary of this idea of raising this level of abstraction. The second idea is that the sensors should really be inherently data-centric. And so what we mean by that is that, the traditional paradigm is very much focused on models, right? Everything is surrounding, like you take a fixed data set and you run it along this, you vary this model until you get the best response. Really, we don't want to be doing that. And one of the reasons we don't want to be doing that is because we don't want to be shipping this data around. We want the computation to happen around the data. And then everything else sort of being an extension to that. And so on the machine learning sensor, we're going to have the computation being performed, and then this high-level output, which would be, the label in this case, being shipped around, because then we get this kind of, in essence, sort of a privacy-preserving output being moved around as opposed to raw data. And this also saves on communication bandwidth too, because it's a much simpler piece of information than the full raw data itself. And so, yeah, so fully data-centric input-output behavior. The third one is we want the implementation to be clean and complexity-free. And that's very easy to say, but it's hard to achieve in practice. And so what we kind of mean by this is, for one thing, there needs to be some kind of standard interfaces and mechanisms in place for these sensors to communicate. If I'm trying to speak to someone who, is a native French speaker and I don't speak French and they don't speak English, we're going to talk past each other, right? You have to speak the same language. And it's the same for these sensors. So there needs to be something in place for them to speak the same language. And you can imagine different vendors having different ways that they do this. Maybe they create their own protocols. And right now it's kind of the wild west, right? Like you could potentially pick whatever you want. And so the community just kind of needs to pick something and stick with it. And it might depend on the application. But the point is, like, this will help make the implementation much cleaner and much less complicated. And also we have the data formats here. So this is a picture of VJ, and we have this kind of bounding box here, which says this is where the person is. And we have to tell the sensor or tell the interface where the points on that image where the person's face is. And that might sound like an easy thing to communicate, but like, how should you format that? Should you go left corner first, left bottom corner? Should you start at the top right corner? If you have 3 or 4 vendors, they could use different formatting, and they're not going to be interoperable. You're going to have to do a lot of messing around to get things to work together. And it's just not very user friendly. So this is one of the ideas we want to enshrine. And you can imagine having that for the idea of data privacy too, and secure execution. Like, how should that be implemented? And also software updating. Like, should there be a standard procedure for updating models? Should we even be able to update these models, or do we want to have them just fixed? That's probably going to be application dependent too. And this fourth one is probably the most complicated, but also the most interesting, which is that traditional sensors have data sheets, and these data sheets are used to sort of provide information about the devices, sort of their characteristics, voltage inputs, power consumption, that might inform whether you want to use them for your particular application. We need something analogous for this idea of a machine learning sensor, because it's a self-contained modular device. And this word transparent has a lot of things packed inside of it, right? We want, because we have this machine learning component to it. And so it's going to be more complicated than a traditional sensor data sheet. But it also has to have some kind of explainability of our model. And we also want there to be an element of accountability or auditability of these devices. So if I want to buy a device that works under low lighting conditions, that's something I would probably look up in a data sheet and say, okay, well, this one has very poor accuracy in low lighting conditions, so maybe I don't want to purchase this particular sensor. And so you could imagine these being sort of informative pieces of data that I would use in my selection. And so we want to have this data sheet attached to a particular sensor in general. And we've come up with a few sort of areas that we think would be important to include within a data sheet that I'm going to go through sort of briefly. And a lot of these are going to be very similar to those that you would get in a traditional data sheet. Also, this data sheet is like on one page, but you could imagine this being many more than one page. Some data sheets I've seen 10 or 20 pages, and some of them go many, many more pages than that, depending on the device. But a lot of these areas are going to be similar or analogous. So we will want to capture the hardware characteristics, the communication specifications, descriptions, features, use cases, the form factor of it, and maybe some compliance standards too. But then we have these other characteristics of it, such as our model characteristics. So like, how does the model perform in a particular environment? So if you have a binary classifier, you're going to want to have some kind of precision recall curve, or maybe a receiver operating curve, which tells you sort of the ratio of false positives to false negatives, something like that. Just information about how good the model is that is on this particular device, and some kind of aspects of that model. And then, going beyond that, also information about the data that was used to train said model. And this can come in the form of, something very simple like a data nutrition label, which could tell you something like, okay, well, this data set, does it come from, multiple sources? Is it a government data set? Is it a proprietary data set? Has there been an ethical review on this data set? Does it contain information about humans, or is there any license that's particularly associated with this data set? And you can imagine, like, maybe you don't want to use a device that's been trained on a particular data set because it has inherent biases that you just don't want to deal with. Or maybe you don't want to use it because there's some implications liability-wise on the data set that's been used. And then we go into sort of a very end-user facing section, which would be the kind of security and privacy label, which is, some devices like the Nest thermostat, which has a microphone in. Maybe you would look at it and say, well, okay, so I know this has a microphone in now. Maybe I don't want that. Maybe I'm going to go and pick one that doesn't have a microphone in. And then, maybe some of them would say, I'm going to upload data to the cloud. I don't want that, so I'm going to pick a different one. But the point is, there's an element of transparency here where it's like, I don't have to go and search around and guess and like wait for the news to come up in some scandal that there is a microphone in this device. It is plainly stated in a document for all to see. So there's no hidden information. And then an extra component of that is we have to have this kind of end-to-end performance analysis. So the idea is that the model performance might change based on your environmental characteristics. And you could get very deep into the weeds here because there's a potentially infinite number of environmental characteristics that you could want to capture, such as for the idea of this person detection sensor, it could be how far away from the camera am I? What's the level of lighting in this room? What's the color of the lighting in this room? The angle of the sensor, the orientation of me to the sensor, things about what I'm wearing or the way I look. So there's many different characteristics that could be enshrined in this particular section, but the point is, like, it needs to be illustrative and also just useful for the person who is planning to use this device for that particular application. It's meant to inform the application. And then obviously, compliance standards, like if you're going to use these devices in like Europe, then you want to make sure they're GDPR compliant, for example. Otherwise, you could run into a lot of problems there. And this gives you sort of more credence or like reliability that these devices are legitimate, because if they're certified by third-party entities, that gives you a lot more comfort in their performance. And then the final section is, you want to have some information about the environmental impact of these devices, right? Like people talk a lot about embodied emissions these days, which is, in the production of this device, how much CO2 was produced. And I'm pretty sure this is going to be standard practice within the next 5 or 10 years. So, it makes sense to get ahead of the curve. And there's obviously CO2 is a huge parameter, but you can imagine there being other considerations as well, such as water usage, VOC production, eutrophication potential, and you might want to enshrine these within some kind of environmental impact report that describes the impact of this particular device. And then the fifth guiding principle was, we want to have an open source ecosystem. So we want to help foster that. In the same way that we have this open source ecosystem for software systems, that should be the same thing for these hardware systems, which is, creating good data sets, which are reliable, bias-free, and such models that perform very well in particular circumstances, and also open source hardware. And especially for ubiquitous applications, for something like person detection, where this is something that's going to be across the board in terms of applicability. And you can imagine there's still being bespoke applications that people might want to have intellectual property for, and that's totally fine. But we want to have this open source community that we help foster as well. And to that end, we made this website here called mlsensors.org, where you can go and check out our white paper, our GitHub page, and also reach out to the team, which includes myself, if you want to get involved with a working group. And one of the next things we're working on is this idea of what should this interface look like that I described, of how these sensors are going to talk to one another, what the standards are going to be. So this is like, what should this data sheet look like? Does there need to be any oversight mechanisms in place for these data sheets that we're describing? And then also things like the ethical implications, right? Because like any technology, there's some unsavory applications as well as the socially impactful ones. Particularly for TinyML and ML sensors, you could imagine things like, if I can do person detection, I could put that on weaponry. If I can do facial recognition, I could also target particular ethnic groups. So, within these ethical considerations, you want to know what is an acceptable use case and what is not an acceptable use case, and how do you sort of bridge the gap between the two, where you allow these socially impactful applications to go ahead while also limiting the possibility of the unsavory ones. So just to recap those 5 guiding principles, we have, we're trying to raise the level of abstraction, and this is to sort of increase the usability and user friendliness for developers to produce things with these machine learning sensors in the same way that we do with traditional sensing components. We want to have a data-centric workflow, and this is largely to empower end users. If I bought a TV that had a machine learning sensor on, I could be much more confident that my data is not being harvested by the person who I bought the TV from. And I would also, they would win brownie points with me because I would tell by the fact that they were using the sensor that they cared about, protecting my data and stuff. We also want it to be clean and complexity free. And again, that's to do with creating these standard interfaces, which are simple and easy to use and interoperable across these sensors. And this allows for things like composability of the sensors. So you can imagine in the house of the future, if I have 20 of these devices, like one on my toaster or my microwave, and I say something like, hey, Google, and then all of my devices turn on, that's kind of a nightmare, right? But if you have an extra component, which is maybe a gaze detector, which can tell when I'm looking at it, and then only the thing that I'm looking at will turn on, that's a much more useful application. So, there's this composability idea of these sensors, and we want that to be as sort of seamless and easy to integrate as possible. Then we have the idea of this transparency with the data sheet, which also provides you with some level of explainability, some level of accountability, and some level of auditability by these third-party entities. And then also the creation of this open source ecosystem, so that people can get involved and develop these open source solutions to at least ubiquitous problems such as person detection. And so we're lucky to be working with the Harvard Radcliffe Institute, which is, they're renowned for taking technological innovations and basically linking them with policy experts to help sort of generate policy recommendations. And so this is something we're doing in the summer to basically help build up that idea of like, what should that interface look like? What standards should be in place? And what are these ethical considerations that, developers and manufacturers should have in mind when they're sort of developing these devices, and how should that be enshrined in this idea of a data sheet? And so that's all I have for the talk specifically. So thank you very much for listening. If you want to know more, please feel free to go to the website and read the white paper, or reach out to me or anyone else on the team if you want to get involved. And yeah, so thank you very much for listening. And I'm open to questions now for the next like 10 or 15 minutes.
Thank you very much, Matthew. That was a great presentation. A round of applause from me and from all the participants. And Jeremy, do you want to moderate the Q&A?
Matthew, you've got access to the chat. There are quite a few questions in the chat.
Oh, I see that, yeah.
If you answer one, can you read out the question?
Okay, so the first one I'm seeing is, how can you tell if the sensor model is working correctly? Do you need to ground truth yourself every so often? So Andrew, I think you're saying basically like you have model drift, right? And it's like, how do you account for that? Okay. So yeah, I guess this gets into like the idea of, you know, how would you do ML ops on a machine learning sensor? That's a very open question, I guess. Something needs to be discussed, especially with the idea of like software updates, right? Like if you have only this access to this interface, how do you change the model if you need to? And that's definitely something that we're still like, okay, well, there needs to be a mechanism in place to do this. We've developed our own sensor right now, and the way we do it is we have basically one board and then a second one attached to it. And if we want to update the model, we attach a second board and plug it in, and then it loads the model onto the second one, and then we just break that board off of it. So it does allow some updatability, but it's a bit of a hack at this point. But yeah, it's a very good question and something I don't have the full answer to at this stage. But thanks for bringing it up. So the second question I'm seeing is from Segun. I hope I'm saying that correctly. It says, how do we differentiate ML sensors and IoT, since both are collecting data, processing, and reporting to a location? So I don't see it as being particularly, it's definitely similar, right? So we described it, we've been writing a CACM viewpoint about this that should come out shortly. But I feel like it's just a new paradigm of sensing, which essentially does a very similar thing to IoT, or TinyML at least. But it's different in the sense of, you know, you have that machine learning and sensing component, and they're kind of logically separated from this application processor, and they're connected in this modular environment. And so I don't know, does that kind of answer your question? Maybe I'm missing something.
I think Andrew has a question. Are you on mute?
Yeah. Sorry. Let me get back to you real quick.
Okay. Matthew, are there more questions in the chat? I saw something.
I see another one from Andrew, which says, is your group coming up with the guiding principles? The answer is, so this is like a collaboration with, it's us, it's also Stanford, and Brian, actually, who's, you know, kind of the MC here, one of the MCs, and he's at Barnard. So several institutions, and we've sort of came up with these ideas. Obviously, it's very much in the early stages, and so I imagine these principles are going to evolve as time goes by. Specifically, once we've gone through that process of describing the interface, the standards, and the ethical considerations. Yeah, and do you have anything to add, Brian, to that?
No, I mean, I think like the hope here is that we can start to build a community effort to think about this. And so our goal was not to say that like this is the end all be all, but this is sort of the right direction to move in, and that we should be moving in this direction, and we need to think about sensors, to think about data sheets, and we need to think about these guiding principles. And here's like a very good stab at what we think it should be. And then please give us feedback, because I think I've just found in general, sometimes you have to put something out there, you know, in order to, like, we can talk about it all day long, but until somebody puts something down on paper and says here, you know, you often don't get the kind of action that you need to keep things going. So that was sort of like a lot of our impetus for why we wanted to do this.
That makes a lot. Sorry, I remember my
Yeah.
question. I
We
apologize.
just want to start a conversation, basically, is the idea here. Because we think the current paradigm is, while it's good, there's a lot of problems with it, and it can definitely be improved. Whether this is the solution remains to be seen. But you know, if we reach for the next thing and we get like half of it right, then that's a good starting point, I would say. So.
Cool. This is awesome. This is really very interesting. And I guess one of the things I'm thinking about initially about sort of like starting this initiative, like you can do this in your home as sort of like a first step kind of thing. But you know, once that gets worked out, and like how do you, you know, make sure you're living in a safe space, then what do you think of like the ethics behind sort of like, you know, taking it out into the world? Like what does that mean?
Yeah, so I think the impetus for us doing this was VJ was telling us one day that he bought a new TV and he was doing some yoga, and the TV was like, "Oh, do you want us to do pose estimation of your yoga?" And he was like, "How can you do pose estimation? You need a camera to do this." And then he realized that his TV had a camera in it, and he just had no idea that it did because, you know, it didn't look like it did. And, you know, we discussed this and we were like, well, if a professor that studies edge computing does not know his own television has a camera in, then, you know, what hope do the rest of us have? And so really, I mean, if you go and speak to any cybersecurity expert, they'll tell you the sort of biggest problem that they expect within the next decade is IoT security. And you're also seeing billions and billions more of these devices produced every year. And I think it would be very easy for us to sort of sit back and not think about this, and for it to become a massive issue very quickly, just because there's currently no solution in place, or people thinking about, okay, well, how do I implement procedures which, you know, have some kind of like privacy by design within it. Often privacy is like an afterthought, or, you know, there's some kind of retroactive stuff done. And we were like, okay, maybe we should be taking a proactive approach, because otherwise you could have, you know, very invasive things going on in people's households where, you know, you have 50 cameras and, you know, all of these companies have access to it, and they're just exploiting the information to their own gains. And we wanted to do the opposite of that and sort of provide a mechanism to empower the end users, or at least start a conversation that would put them at the forefront.
And so do you think that when you're starting the conversation, at least for the platform, right now, are you kicking off the conversations and having certain groups attached to particular sort of like spaces of the conversation, like sub conversations, or is it just like one big one right now? Like
yeah, so for the Radcliffe seminar particularly, we have like some policy experts that we're bringing in, IoT experts, people that are, you know, very renowned in the sort of machine learning community or TinyML community, to come in and say, okay, while keeping everybody's interests in mind, like we also want to make sure that, you know, these things are not psychopathic in how they work. And we also address some of the concerns that people have about IoT and security, and, you know, what considerations you would have to have if you were going to, because the most common application for these devices is probably going to be in people's houses. You can imagine it being in commercial environments too, or, you know, things like that. But I feel like when most people go to a mall right now, they're just aware that there's 50 cameras on them at all times. But, you know, if someone has a camera in their bathroom, that's like a much like less nice thought to think about. But if you had the assurance from an ML sensor that, okay, like this data is, you know, it's you cannot access it no matter what you do. So it's technically safe. Like, how would that affect public sentiment? Maybe you'd be a lot more open to it. I imagine there would still be pushback in that particular scenario, but, you know, it's hard to say because this just hasn't been implemented yet. But I feel like it's going to happen within the next decade or so. Okay, so I said, oh, you also asked, are there any example data sheets? So the short answer is yes. I think in the white paper we produced, there is an example data sheet. I can't remember for sure. Do you remember, Ryan?
Yeah, we've got like a 1-page mock-up. It's not it's more illustrative than, say, an example.
Yeah. We are developing like an actual one.
Yeah.
But obviously that takes time. And I would say the most complicated aspect of that is the end-to-end performance, because you get into sort of a very scientific realm of, I have to do a study which is representative, and I consider all of these various environmental parameters and like how they vary and how the parameters of the model vary based on those changing parameters. So.
Matthew, lots of products have lots of ML sensors in them. Are you thinking of eventually, like, I'm assuming this is just the sensor that's in a product. Can this be expanded to products that have multiple sensors in them in a way of organizing that information? Did that make sense?
Yeah, so you mean like you might have a product that has multiple of these devices in, right?
Yep.
Yeah, so that's again, like, there's a lot of implications when you try and change like a paradigm, and definitely the ramifications of this for certain technologies, like some are going to use way more ML sensors than others, and some people might not want to use ML sensors. And then I think this kind of speaks to this idea of the composability that we had, where it's, if you have multiple sensors, you can get augmented functionality, right? If you just have a person detector, it can do one thing. If you have a gaze detector and a person detector, you can put those together to get some kind of augmented functionality. But you're getting that functionality, but you're also not doing it at the cost of consumer privacy. So you're still able to get, if you did it well enough, and if you maybe use third party tools and extra stuff, you could probably still get the same functionality, but you would probably get a lot more brownie points with consumers for trying to consider their privacy as well. But yeah, I mean, it remains to be seen whether this would actually be adopted by companies and their products, or whether it's kind of a gimmick at this stage. But I feel like it's something that we have to try and see. And definitely when we're developing these like interfaces and standards, we need to have people at the table who are part of those communities so that we can discuss kind of what would incentivize them to use such a device.
There's a question here. Why didn't you call it AI sensors instead of ML sensors?
Well, I guess an element of that is just one sounds better than the other. But yeah, I don't know. I guess there's many things we could have called it. But I feel like generally, we have TinyML already. It's not called Tiny AI, although maybe some people use that term. So yeah, I guess that's just a choice that we made. You could call it whatever you want to some extent.
I think you also could argue that the important notion here is that there's a data reduction happening, where we're going from the raw data to some summary information. And I guess there are multiple other AI algorithms you could use for that, but machine learning seems to be like particularly good at doing this sort of data compression type technique. So maybe that's a good argument. But yeah, you could go either way.
Yeah, I would agree.
By the way, Matthew, great presentation. Really clear and really interesting. I love your term at the moment that where we're at with sensors is a wild west. It's perfect. I get new sensors in my classroom and I just give them to kids. And if I hand out 6 new sensors, I'm super happy if they get 2 working. Sometimes it's really frustrating with something new, even if you know the communication, it's SPI or it's I2C. So yeah, I really feel like it's a Wild West at the moment, and hopefully what you're working on can make it easier and more confidence when you purchase something, that you can actually get it working.
Yeah, right. Imagine if you could just buy 6 and you have 6 of them work immediately. Like,
yeah, exactly. More questions here. I know there've been a lot of questions and some are getting lost. Marco, we have a bit more time, don't we? And I guess it's up to you, Brian, how much time we have.
Go for it. I can be quick too. That's easy peasy.
Yeah, if you have a question, you're welcome to re-ask it.
I think there's one that got missed that was around the life cycle of the sensor. So I actually think this isn't something we have planned on testing, but would be very cool is how does it work as the battery performance degrades over time? That's actually really interesting.
Oh yeah, that's a great question, and my answer is I have no idea, unfortunately. But yeah, that's something we should definitely think about. So thank you.
Can you purchase these sensors already? Like, is this open source at that website? Are these like?
So you can't buy the ones that we made, although, you know, we're planning within the next maybe 2 months to have basically the entire software workflow and also just hardware details for people to go and sort of build their own and just use our model on it. We also have one of our collaborators, which is this company Useful Sensors, which is Pete Warden's company, if anyone's familiar with his work. And they have a commercially available sensor that they're selling at this point. And we're working on a study right now where we're evaluating our sensors, but we're also doing it alongside his company's sensors to sort of give a comparison of how that works in this kind of end-to-end performance analysis. So yeah, you can technically buy them. You can't buy the stuff that we've done. It's not fully open source yet, but it'll be here by the summer, I would imagine. Are there any more questions?
I guess I have one more question about the composability.
Sure.
Have you experimented with, I guess, like, to what degree of composition have you like experimented with? So you had like, you know, two events there, because this is essentially like a giant event driven sort of system, right? So like, is there a limit to the number of events that you can trigger in any given like network kind of thing? Have you guys experimented with that, or like does that rate at some point like kind of fall apart, or is it too much or something like that?
So that's an excellent question, and in full honesty, we have not actually achieved composable sensing yet of an ML sensor. That is something we have on the to-do list, I guess, but we have not done yet. We thought we would try and build a single one first before we try and start composing them. But I think the lowest hanging fruit there would be the one that I mentioned of you take a person detector and you link it to a gaze detector. Because that will be a very common use case in the future. For example, like maybe your TV turns on if you are sat down in front of it and you look at it, something like that. So yeah, I think that's probably the easiest thing to implement. In terms of like, if you could have 5 or 10 of them running at the same time, that's an open-ended question, I guess. And it's definitely something to think about when we're designing this interface, because I imagine there will be an interface to, you know, the external processor, and there might be a separate one which is connected to other ML sensors, or maybe we can try and combine the two of them. But yeah, like I said, it's pretty early stages, so it's hard for us, for me to say for sure like what it would look like or what the limits would be. But it's great that, you know, you're asking these questions, because, you know, half of these I haven't even thought about, so it's helpful for me.
Matthew, the TinyML
Yeah.
community is really, we do a lot of work using Edge Impulse, where it's mainly motion, camera, and sound. What you're working on is way more types of sensors and types of data. Are you looking into any work? I think it was your rule number 2, where getting the data in an organized format, I assume for uploading to something like Edge Impulse. Is that kind of connected slightly with what you're doing?
Absolutely, yeah. So the open source sensor that we're developing, the software workflow, uses Edge Impulse, and we'll be releasing basically the entire workflow for people to, look at and play around with. So, because we wanted it to be as sort of easy as possible, and I feel like Edge Impulse has a very easy interface to work with in building these models. And I imagine the open source community, they're going to be using some kind of system like this to develop these models for future applications. Although I guess, it's very easy to do it with like images and stuff, maybe for like more or like less ubiquitous or like data sets that are slightly more nuanced, it would be harder to do. But that's something I envisage that the community is going to be using a lot of.
I think Brian and Marco would agree that it's too bad Marcelo wasn't here today, because he's really interested in that area of other sensor information, getting it onto Edge Impulse. He's got multiple ways to load things onto CSV files.
If I may add just a short comment, is that I think this is really, really good for scalability, right, and sustainability. So a question that comes out when you talk about, TinyML, people start saying, that's okay for a prototype or for a pilot project, but then how do you scale it up? And I think this really goes in the direction of, scaling things up. So it's great.
I guess I have a question about scaling things up. And when you think about it for like the perspective, so from a home security perspective, have you guys thought about scaling it up for, like, say you own multiple homes or something like that? What software, or what, like, would it be Edge Impulse that sort of like manages this sort of like top level information store of, okay, like I have these sensors in my homes or like places I go to, do they can that centralized hub be Edge Impulse, or do you envision it to be something else, or some separate third-party software system kind of thing?
Well, I mean, I'm not a spokesperson for the company, so I have no idea what they might want to try and do that and branch out. But I think it's hard to say at this point, because we literally have made there are like 2 of these in existence at this point. But yeah, I could certainly imagine there being some kind of like management mechanism especially in smart homes, if you start having like 20 or 30 of these across various aspects, like even lighting. Let's say it was controlling your lighting system. That's already going to be like 10 or 20 sensors within your house, right? If you have like a normal sized house with several rooms. So you can imagine very easily it's sort of starting to scale within a single person's house. If you have an entire apartment building, that could be thousands and thousands of sensors, and you would have to have a way to manage that or something. Especially in terms of like, if you wanted to do software updates and sort of, shoot it out to all 1,000 sensors controlling the lighting system, something like that. So there needs to be some kind of mechanism to do that, and then also some oversight mechanism as well, I would guess.
Super. So thank you very much, Matthew. That was a great talk and great Q&A section.